Right triangle means to find all the lengths of the sides and all the measures of the angles. How many answers will we have? Six. Alright, in our first example, you're given a diagram. You may be given information in a list. It may be given to you in a word problem, but you want to set it up so you can draw them. Now, there's a certain naming system that we use, and that involves the fact that we're going to use capital letters to represent the angles, and then the corresponding side, which is going to be located across from the angle, is going to be using the lowercase letter. Right? As we go through this, don't be confused. C may not always be the right angle, which means C may not always be the hypotenuse. Why would she be telling us this? Well, in the Pythagorean theorem, a squared plus b squared equals c squared, correct? But that only works when c is the hypotenuse. So don't just automatically substitute letters until you evaluate whether or not side C is the hypotenuse, if you're going to use the Pythagorean theorem. So this is called the standard lettering for any triangle. Here's our example. We're going to find all of the lengths of all of the sides. Alright, so 61.7 is A. Which ones do we need to find? Angle B. Can we find that very easily? Yeah. Yep, use your calculator or your brain. Use the 180 rule. What do we get? 28.3. There it is. Okay, so we found angle B now. The work involved in this is only going to be to find side A and side B, correct? Now, as a rule of thumb, I would do this. I would always choose an angle, an acute angle, that is given to you. It's not that you can't use the 28.3. You'll get the same answers, but if you made a calculation error with this, now everything else you do is wrong. So the more you can use the given values, the better in terms of getting the right answer. So we have these trig equations. We did this in a previous unit. In a trig equation, we are always going to have whatever the trig ratio is that we choose. We are going to have an angle. It can be x or theta. We have an equal sign, of course. And then we have a ratio of two sides. Those sides involve the letters OA or H. Now, if we take a second to look at the calculators, look at your calculators, please. Do you notice that there's only 3 buttons on the calculator? Sine, cosine, tangent. So, moving forward, when we deal with inverses especially, only choose trig values that are sine, cosine, and tangent. That's why your calculator is going to help you with this activity. So, when I look here, I'm going to take this angle that I'm now highlighting, and I'm going to call that my theta angle. If that is theta within my triangle, this is going to be my adjacent side, my opposite side, and my hypotenuse. You don't have to label these. You can mentally calculate them, but you want to definitely associate A and O based on where you chose theta. If you had chosen angle B as your theta, you recognize this would no longer be A. Okay? Kind of just a brief overview there of thought process. So, let's say that we wanted to solve for side A. Okay. Does this red A mean adjacent? No, it's just a label given to the side in the triangle. It's actually the opposite side. What other side do I have? I have the hypotenuse. So if I'm going to associate O and H, what trig ratio is O and H? Sine. So I'm going to say the sine. Now, for the angle, I'm going to use 61.7 is equal to the opposite side, which we can call A, over 106.2. Now, this is a proportion. Okay? If I put this over 1 and I want to solve for A, don't I need to get rid of the 106.2? So I simply multiply both sides by 106.2. Take this times 106.2, cancel, and I can put this into my calculator. Does this say to use sine inverse or sine? Sine, regular old sine. So please put all of this into your calculator. 106.2 times the sine of 61.7, what do you get? A is equal to what? 93.5. Okay, now let's solve for B. Again, use as many given values as you can. So B in this triangle is actually the adjacent side. We were given the hypotenuse. What relates A and H? Cosine. So I'm going to say the cosine now of 61.7. We know the angle, so we're going to actually call it 61.7, is equal to the adjacent side over the hypotenuse. If I'm going to solve for B, what do I get? Multiply by 106.2. 15 point. We now have solved for all three sides and all three angles. It was that miniature happy face that you had the right answer. Questions on example 1?